Clustering, datasets, code. It can feel like a maze, right? But not with KMeans. This powerful algorithm breaks down data into meaningful clusters, making complex patterns easy to understand. You'll wonder why you ever struggled. Welcome to day 18 of the 30 Days of Machine Learning series. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. And hey, make sure to hit that subscribe button so the next video in this series drives straight into your feed. In this video, we're diving into the world of K-means clustering. We'll take a dataset, break it down, and write code to create clusters from scratch. No fluff, just practical hands-on learning. So, if you've been struggling to get K-means clustering right, stick around. By the end, you'll not only understand it, you'll be able to implement it confidently in your own projects. First, we're setting up the essentials. Loading libraries for data manipulation, numerical operations, and visualization. These are the backbone of any ML project. Let's load our dataset into a data frame and take a quick peek at the first few rows to understand its structure and contents. Now we're checking the dataset's size, exploring its column names, and getting a quick summary of data types and missing values. Our data overview step. Here, we're identifying any missing values and diving into the dataset's statistical summary to uncover patterns, ranges, and potential anomalies. We're plotting a scatter plot to visualize the relationship between age and spending score. This helps us spot patterns or trends in the data. Here, we're visualizing how age correlates with annual income. This plot might reveal clusters or trends crucial for understanding income distribution by age. This scatter plot shows the relationship between annual income and spending score. It's perfect for identifying spending patterns across different income groups. Now we bring in K-means from scikit-learn, the hero of this video, to help us cluster our data into meaningful groups effortlessly. Here, we're fitting K-means for cluster values ranging from 1 to 9, calculating the sum of squared errors, SSE, each time. This allows us to visualize the elbow method and decide the ideal number of clusters for our data. We're plotting the SSE against the number of clusters to visualize the elbow method. The point where the curve flattens indicates the optimal number of clusters, helping us make the best choice. Now we're setting the number of clusters to 5 and using the K-means model to predict the clusters. This gives us the cluster assignments for each data point in the dataset. We're adding the predicted cluster labels to our dataset as a new column. Now we can easily track which data point belongs to which cluster. Here, we're splitting the dataset into 5 separate data frames based on cluster labels, making it easier to analyze each cluster individually and understand their characteristics. Here, we're plotting the 5 clusters with different colors, showing how the data points are grouped based on their annual income and spending score. Each cluster is represented in a unique color, and the purple stars indicate the centroids of the clusters. This visualization helps us see the distinct groupings, making it easier to understand how K-means has categorized the data and where each cluster's center lies in the feature space. That's a wrap on K-means clustering. We've broken down how to segment data into meaningful clusters and visualize the results. But we're just getting started. In the next video, we'll dive into hierarchical clustering, exploring single and double linkage methods to create clusters in a different way. Curious to see how it compares to K-means? Click on the screen now to continue.